E503 Project 3 video submission. To start with the code, we define everything. Section 2 here is for part 1 of the Project 3 assignment. Section 3 is for part 2 of the assignment. I defined sine amp here. It's a variable that determines the amplitude of the sine wave oscillations we'll get into later. And then section 4 is for part 3 of the project. I added some values to the time and the irradiance to achieve steady state to prevent transients from affecting the results. And moving on to project 1. This is project 1. Phi is defined by the step value. It goes from 1,000 watts per meter squared to 400 watts per meter squared. VDC nom is a constant 250 for this portion. This is fed into a 1D lookup table to determine the maximum power point, and it also goes into this 2D lookup table to determine the current coming out of the photovoltaic. This is the switch for the boost converter. This is the PI controller. This is the external switch behavior, how the rest of the circuit sees the switch. You have the parasitics for the path when it's closed, the parasitics for the path when it's open. Here's the Thevenin voltage used in calculations. Here's the inductor. Here's the capacitor. And here's where I output the values to Simulink for calculations. For this first one, the big thing here is really this step value from 1,000 watts per meter squared to 400 watts per meter squared. Moving on to the second portion. The second portion has an oscillatory voltage bus, but it does have constant irradiance, which is why there's a constant 1,000 being fed into Phi. It's the same circuit over here. The only difference is now we're oscillating with VDC bus, and the results of which can be seen in the project document, but can also be seen down here, such as the ripple voltage with 0 oscillation, with 1 volt peak to peak oscillation, and with 10 volt peak to peak oscillation. Then we get on to part 3 of the simulation, and for part 3, I had to load in a few values for this lookup table. VDC nom returns to constant, which is why it's a constant block again. But this one is based off of a lookup table, and going back to adding data to the lookup table to get rid of transients, because this data starts at a specific value but then immediately begins to change. I added a few values to assume that it was at that starting value for a while to allow the capacitor, the inductor, all the circuit components to achieve steady state. So this clock here feeds into this 1D lookup table, which is this graph right here. As each second goes by, it projects a different value onto this graph for Phi. And yeah, the circuit is mostly the same. The only difference is this power block here. I wasn't able to get MATLAB to convert power as efficiently as I wanted to. This was a mistake on my part, as I found out that I was asking it to do the wrong thing. But this block wasn't throwing any errors, and if it isn't broke, don't fix it. So that is why this block is still here. Aside from that, I believe that concludes the video submission for the EE503 project. Thank you for your time.